Let's see, let's have a look at the maths now. Okay, which one? This one. Let's have a look. Yeah. Okay. Let me just roughly draw it. This starts out A, B, C, D, E, F, G, H, I, and it's B, A, B, C. So this vector and this vector. And we're looking for DE. Okay. So you could say DE equals DC plus CB plus BA plus AG plus GF. No, sorry. DC CB plus a half. You know what? Let me just get straight to the answer. DC is minus BC, and then this one minus BC, and then here that's a half BA to get to here.
How?
What do you mean how?
How did you do it?
I'm going. Start here.
But you want
go left.
You want DE.
I know, I'm getting there. Minus BC minus BC plus a half BA plus BC plus BC plus, let me just call that one XE. I just went this way. Around like that.
Now you want make the two vector DB and B2 minus half BA.
Half BA, yeah. This. A long way around. That cancels that. That cancels that. So you're left with a half BA plus XE. Suppose I could have just done that at the start.
But this don't give you DE, give you from D to E.
No, this gives me DE. Because I start here and I finish here.
Is it the parallel true?
No. I start at D, I finish at E. No? No, give me a question. I need a question.
How did you start at E? Like,
I start at D.
What is your idea?
I start at D and I move left. So that's that one. I move left again. Up, right, right, right.
What is BC?
This one. That's BC. Minus BC. isn't it?
But how this equal D to DE?
How?
How all of this equal to DE?
Because I start at D and I finish at E. No. What? Oh, Miss Sharif, my heart. Look, look, look. I start at D. What's D to C? That's the same as minus BC. So I start here, now I'm here. Minus BC. Now where am I?
Yeah.
B, yeah? Plus a half BA. Plus BC. Plus BC. Plus XE. Now I'm back at E. No? What's confusing you?
From D to X, it's very long. How could all of this equal to DE?
It does. How could this equal 4x? It's very long. It doesn't matter. And anyways, it's not very long because some of this cancels. So it's just a half BA plus XE. Which makes sense because it's this one plus this one. This plus this, yeah? Are you happy with this for DE? DX plus XE? Maybe you prefer it that way. I thought I was doing a way you prefer. DE is DX plus XE. That's a half BA plus XE. Is that okay?
And this is the Bharat.
No, this is just what we did yesterday. D to E is D to X plus X to E. Here to here is D to X plus X to E. I don't know, I don't believe you. Are you okay with this? Why not? We did this yesterday. Like, I mean, you understood it yesterday, so what happened last night? You fell asleep and you lost...
No.
Oh, you didn't understand it yesterday?
No, I did.
Yeah?
But it's like, you have to make a para.
No, you don't have to.
You did?
No, yesterday when I was doing the square, remember? Like here's A, here's B, and here's C. And you could say AC is AB plus BC. The same idea. DE is DX plus XE. It doesn't, it only has to be parallel if you want to say BC is the same as AD. It has to be parallel. But it doesn't have to be parallel if you want to say DE is DX plus XE. Yeah? It doesn't have to be parallel. It's only parallel when you want to say this is the same as this one here. But I'm not finished because we want this one, but we don't want this one. The XE. X to E. So we're going to need to find out XE. Now I think maybe you were saying, or someone was saying, maybe this is the same as BC, but it's not, it's shorter than BC. If I draw here, if this is 60, this is 60, and if this would be half a unit, this would be half a unit. and we'll call this side x. You can say tan 60 is x over a half, so x is a half tan 60. What is a half tan 60? Let's see.
How tan 60?
Oh, Namu Sharif! Please, this is from semester 1. Opposite over adjacent.
Yeah, but how adjacent half?
How big is here to here? 1. So, here to here? Half. Yeah? No?
But it's not given.
No, but that's why I said 1 unit. I don't, yeah, I know what you mean. I don't know the length, so I just call it like 1 unit. But I don't know, maybe it's 1 meter, maybe it's 1 centimeter, I don't know. So that's why I said 1 unit. So this is like half a unit. And here 1 unit is this, like the side of the square. Okay. I thought you were asking me what's this. Would it be heartbreaking? Do you have your calculator? Can it give nice answers or only decimal answers?
No, decimal.
Okay, decimal's fine. What have we got?
Tan 60 multiplied by 5
Yeah.
equals 0.866.
0.866. Okay. 0.866 units. Yeah. So if you go back here, what I'm saying is, if this is 1 unit, then this one here is 0.866 units. So this is a half BA plus 0.866 BC. This is like BC, except it's a little smaller. So this is the answer here. Okay. Hard. Yeah. The last part actually isn't too bad. BE. BE come in. Who have I got? Iyad. BE is BD plus DE, which is twice BC plus this answer, a half BA plus 0.866 BC. Is okay? 2.866 BC plus a half BA. That's BD. Okay. Okay. You don't like them. What do you mean? This or vectors? This type. Not this type. Like this type, no. But vectors is common. Every exam has vectors. In section A and B. This is bad news?
No.
It's good news?
No. I don't know how it's vectors.
We haven't done enough of the chapter. We're not quite at exam questions yet, you know. We still have... Next we have this to do. And then we're getting closer to doing exam questions. This is more like the exam, the next lesson. Jeepers. You probably want to write this down? Or not? Okay. You don't? You usually write everything down. You don't want to write this down?
Because I want to understand it until I watch it again.
Okay. Did you do vectors in high school or
Yeah.
college? So,
I remember only how to multiply.
that's the only thing you remember? You have it? Yeah. Okay. Let's have a look. Right, do you want to write the next lesson down? So this is what we're going to have a look at. Position, vector, and triangle law. Got that? Yep. Okay. So now, let's imagine we have some point. Let's say A, let's say B, let's say C, and let's call one point the origin O. So these vectors are quite common vectors. OA, which is this vector. There's OB, and there's OC. So these vectors where we have an O at the front, we start at the O, these are called position vectors. And to make life more convenient, we don't usually write the O. So we usually just write it as A, B, and C. So if I wanted this vector, I don't have to write OA. If I start at the O, I can just write A, this one's B, and this one's C. So Euclidean vectors, they're still like Euclidean vectors, except they always start at O. And in fact, it doesn't actually matter where you really put the O for some of this stuff. So I'll show you an example of our first law. Let me just draw it again here, but I just want O, A, and B. So there's vector AB. We would like to make AB a position vector, but it's not clear because it doesn't start at O. So we're going to have to go a different path. So we can say AB is the same as AO plus OB. So we can go this way, and then we can go this way. But AO is the same as minus OA plus OB, which is OB minus OA. But OB we can just call it B. And OA we can just call it A, yeah. So in other words, we have this law, which is called the triangle law. The vector A to B, if you want to write it as position vectors, it's position vector B minus position vector A. This is the triangle law, and this is the proof for it. And this is the triangle law. A very simple law, but very useful law, because it makes a Euclidean vector a position vector. So this is like our first law. Okay, so once you write that down, we'll have a look at how to use these. What are you translating? Or who are you texting then?
The family group, my brother, internal to them.
Oh, family group.
Yeah.
Ah.
Yeah.
He has part of his brother in his bag, don't you?
Mm-hmm.
Yep. Yep. He'll explain later.
He told, you saw him, he lost his tooth. Oh, yeah, and now he wants to.
So you have the two in the bag.
No.
Oh, I thought you did. Is that home?
No, in the bag was not real tooth.
Not real tooth.
Yeah.
What do you mean? Is the thing you put on top of your tooth?
Yeah.
What are those called? Crowns.
Yeah.
Yeah.
It was not explained.
Doesn't translate. Is there something you put on the top of your tooth?
What do you call prosthetic? Like.
Ah, like okay, like this. Yeah. Oh, so it's not real. Oh, well then that's not interesting. I thought it was real.
I can write also like A minus B.
No, it's B minus A, not A minus B. You can write minus A plus B.
Yeah.
Okay. Continue. Not yet. I suppose Adnan and Mir are finishing their lab reports. That's why they're not here. Is yours finished? Do we have physics later today? Yeah, okay. Yeah, okay. So let's have a look here. Let's do the first one together. There's only 5 questions in this worksheet. Express each of the following in terms of A and D. Okay, so let's draw this. We've got this shape. This is A. Now, this is the O here. this is A, this is M, this is C, this is D, this is N. This splits this in half. This is the same as this, and this splits it in half as well. I won't write that in, it's a bit messy. So M is in the middle and N is in the middle, and O is in the middle here of these two. And also A is 3 times the length of C. So A, which is OA, that's 3 times the length of C, which is OC. So in other words, if this is 3 units, this one here is 1 unit.
And CN equals ND.
CN equals ND. Yes, yes. Okay, so let's see the first one. Oh, and we're looking for it in terms of A and D vectors. Right, so the first one is B. Okay, so B.
Where is B?
Yeah, where is B? Oh, it must have been here. It got cut off. I don't know how that happened. So B must be there. There's no other points left. So B, I'll have to fix that later. B, that is the same as OB. Now OB, we want to try and use A's and D's. So we could say OB is OA plus AB. No, that's not good. I need to go some other way. I need to get D into it. Yeah, OB equals DO, which is equal to minus OD, which is equal to minus D. Okay, that's the first one then. B. C. So that's OC, which is it's the opposite direction, so it needs a minus, and it's 3 times smaller, so it's minus 1/3 A. Okay, C, BC. Okay, well that's actually, if we use our triangle law, BC is C minus B, which is minus 1/3 A minus minus D. So it's minus 1/3 A plus D. So I don't even need to look at the picture because I can use my rule. D, M. Well, M is in the middle of AB, so it's just a half AB. Do I know AB? Oh no, I don't actually know AB. So maybe I want to... Oh no, it's not. I'm sorry. M is OM, which is OB plus BM. Now OB we know. Do we have anything for BM?
What's M equal?
Huh? What's what equal? No. Do we have to work out BM? Because we don't actually have BA. But that's okay, I guess, because this is B plus a half BA. BM is a half BA, isn't it? B to M is a half B to A. No, I'm still not there yet. B plus a half A minus a half B, if I use the triangle rule, which is a half B plus a half A. Now, the A is good, the B is bad, but we know what the B is. It's minus D. So it's just going to be a half D plus, this is a plus here, I think, from there, plus a half A.
But
Yeah.
B is minus D, isn't it?
The B is minus D, you're right, thank you. So I should have had a minus here then. Yeah. Okay, and then lastly, I want to try and get all the answers on the screen. E is N. Is that easy or hard? N. N is ON, which is ON.
ND plus D.
Yeah. Yeah, I guess that's not so hard. ON is, what am I saying? OC plus CN, which is C plus a half CD. C plus a half CD.
OD plus DN.
Yeah. OD plus DN. The same. I don't really care because I know what C is. It's minus a third A, so I can easily change it. So that would be C plus a half D minus a half C, which would be a half C plus a half D. The only problem here is the C, which I know is minus a third A. So the final answer is minus a sixth A plus a half D. So they're okay. I mean, they're not hard, and I know they're not easy, but they're okay. It's all about the picture. So I don't think you need to write that down because that's in the question. These are all the answers here. So if you want to write these down, yeah. Let me just sharpen the focus here a little bit.
Question.
Yeah.
Okay, C plus a half CD.
Which one am I looking at
The
now?
last one.
Yeah.
We used the rule half CD and made it half D minus half C,
Yeah.
right? Where did the C go then?
C minus a half C is plus a half C. So this,
okay.
yeah, I put the two together.
Yeah, alright.
Again, I just want you to see that this final answer, do you see this final answer? You had no way of working that out from the picture. You had no way of knowing that it's a sixth of A and a half of D. So I'm just again trying to show you how sometimes it's necessary to work out things before you can get to the answer at the end.
Did we lose marks if we got the errors?
No. Just remember that they're vectors. Okay, Mushari, you have this? Yep. So let's have a look here. Okay, so like I said, there's not many questions, and they're all kind of the same idea. But now we're starting to get into questions that look like what you get in the exam. I know. Life is very difficult.
Not that.
So let me just, I can close this answer. You have this answer? Yeah.